In order to understand what rate of reaction is in chemistry, let's look at an example. And let's take a reaction equation in which two red particles form one blue particle. And in this example, let's consider that both of these substances are gases. At the start point of my reaction, or time equals 0 seconds, I would expect to have just lots of red particles. And over time, I would expect these red particles to bump into each other, react, and form blue particles. So let's look at 30 seconds. And if we leave it a little bit longer, let's look at 60 seconds. Now it's pretty clear in these diagrams that as we progress along the time scale, I get more of my red particles bumping into each other and forming blue particles. In order to quantify this rate of change, we need to consider two things. The first thing I'm going to consider is how the concentration of my red particles has decreased, or how the concentration of my blue particles has increased. It's valid to use either of those changes in concentration because we have a balanced reaction equation, which means if I know how many of one thing are disappearing, I can work out how many of the other thing are appearing over that same period of time. The second variable I need to measure is the time. This means that the standard units for rate of reaction will be change in concentration units, moles per decimeter cubed, divided by our SI unit for time, which would be seconds. And I could write this in an alternative way by putting moles per decimeter cubed and then adding the second to a -1 on the same line. Let's now summarize the key points from this video. Firstly, rate of reaction is expressed as the changing concentration of a particular reactant or product per unit time. And secondly, the standard units for rate of reaction are moles per decimeter cubed per second. Hopefully, this video was of some help.